because it helps you to be precise. Now, after that, after the identification of the rate, we now move to the fourth element, which is the P wave. So when identifying the P wave, the first thing that you identify is the morphology of the P wave. Is it clear? In the morphology of the P wave, you have to know that the P wave is erect. It is dome bell shape as such. Is it clear? So this is the morphology of the P wave when it is located on most leads, particularly lead 2. When you want to visualize the P wave, go on lead 2 to visualize it. The next element is that the P wave at the level of the V1 wave is going to be having a positive terminal and a negative terminal. Is it clear? So it has a positive terminal and a negative terminal. Now the negative terminal of the P wave corresponds to the left atrium. Is it clear? So that is how you have to understand the P wave. So this is a normal P wave on limb lead 2, and this is a normal P wave on limb lead V1. On the lead V1, is it clear? So this is V1 and it is D2. D2 is the same as the limb lead 2, this is the arterial. So that is the morphology. So that is the main element. The next thing after the morphology of the P wave is you have to know the amplitude of the P wave. The normal amplitude of the P wave is supposed to be 2.5 millimeters, half a big square. Is it clear? Supposed to be half a big square. Now, if you have a higher amplitude, that's a tall P wave. A tall P wave corresponds to an arterial enlargement, as we're going to visualize now in the pathologic ECG interpretation. And you have also in a case where you can have an increase in this part here, that's the P mutually. When you have an increase in the negative portion of the V1 of the P wave, it's a P mutually. Is equal to P mutually, and when you have an increase in the positive portion of the V1, it is the P pulmonary. Now, P mutually corresponds to a left atrial enlargement, as we're going to visualize, and then the P pulmonary corresponds to a right atrial enlargement. So this one corresponds to both left and right atrial enlargements we're going to see later. Now, the next element is the PR interval. Is it clear? For the PR interval, the major element of PR interval is going to be the duration of the PR interval. The duration of the PR interval generally corresponds to 0.2 seconds, and 0.2 seconds is one big square. The length of one big square is 0.2 seconds. So if the PR interval is more than 0.2 seconds, means that there is a delay, and there are different pathologies that correspond to that. And we have also the isoelectricness. Is it clear? Isoelectricness. Is it clear? Particularly if you have a depression of the PR interval, it corresponds to pathologies. In the case of the delay of the PR interval or the lengthening of the PR interval, the disease that we have there are heart blocks. Is it clear? Particularly the nodal blocks. Heart blocks. And in a disease where you have a PR interval in depression, where it is below the isoelectric point, in order for you to know the isoelectric point, you compare both the ST segment and the PR interval. Is it clear? So if you have a depression of the PR interval, it's going to correspond to the early stage of pericarditis. Is it clear? Early stage of pericarditis or stage 1 of pericarditis. So those are different pathologies that you have to visualize. Now, the next element after that is the QRS complex. So for the QRS complex, there are different elements that you have to visualize. The first element of QRS complex that you visualize is the duration of the QRS complex. Generally, the duration of the QRS complex corresponds to less than or equal to 0.08 seconds. Is it clear? So for the QRS complex, the duration is generally less than 0.08 seconds. That's the first element. The second element is the morphology of the QRS complex. So that they are typical morphology of the QRS complex. So this is your typical morphology of the QRS complex. You must have it. Is it clear? The next element of the QRS complex is to visualize for the hypertrophies of the QRS complex. Is it clear? So for the hypertrophy, particularly left ventricular hypertrophy, there are certain criteria that you have to measure for the amplitude of the QRS complex. Now, we have to know that the Sokolov-Lyon index is in order to measure the amplitude of the QRS complex, particularly to visualize a left ventricular hypertrophy. Is it clear? In Sokolov-Lyon index, what we have to note is that you are going to have a very large S wave. So the S1, the S wave on the V1, it plus the R wave either on V5 or V6 is going to be more greater than or equal to 35 millimeters. That is the Sokolov-Lyon. In the Sokolov-Lyon, what you have to understand is that in this index, what you have to understand is that the S wave is going to have an increase in amplitude of the S wave, and you have an increase in amplitude of the R wave. Is it clear? So which is going to show you a right ventricular hypertrophy. Is it clear? So those are the different elements. The next element, you have the normal progression. The normal progression of the QRS complex on the V leads. Is it clear? The normal progression of the QRS complex on the V leads or the chest leads. Is it clear? So the normal progression of the QRS complex on the chest lead states that what? Normally, when you're on limb leads, the chest lead V1, the QRS complex, the R wave is less than the S wave. It means that it is predominantly negative on V1. On V2, similarly, R wave is going to be less than S wave. It means that the S wave, that QRS complex is going to be predominantly negative. The next point is that on V3, the R wave is approximately equal to the S wave. It means that you have something like this. Is it clear? So on the V1, you have something like this. Is it clear? On V2, you have something like this. It means that it is slightly equating. When you are going down to V3, the R wave and the S wave are approximately equal. In V4, similarly, R wave and the S wave component are going to be approximately equal. Is it clear? And now, when you are going down to V5, R wave is greater than the S wave. Is it clear? This R component is greater than the S component, S wave. And then when you are going lastly to V6, R wave is also greater than the S wave. So this R component is going to be greater than this S component. Is it clear? That's the normal progression of the normal progression of the R wave, S wave complex, or the QRS complex. So now you have to know that this helps you in order to visualize if there is any right ventricular hypertrophy, because if there is this interchange of this complex, particularly when the R wave is greater than the S wave on this V1 and V2, is going to show you a right ventricular hypertrophy. So after the normal progression, we have now the next element on the QRS complex that is going to be the axis deviation.